Number 11, you need to take the derivative, but it's specified you need to use the product rule. So they specify you have to use product rule. You can multiply it out and take the derivative to check, but you will have to apply product rule to get the full credit, okay? So this one, the product rule say you write down the first term, take the derivative of the second term, and then this time is going to be additions. Write down the second term, take the derivative of the first part. This is x prime of x. So we have 3x minus 2, taking the derivative of this part, that would be 4 times 2, right? So this would be, let me write down one more step for you. 4 times 2x, right? 2 go down and x go 1 less power, and the 7 will turn into 0. And then we're going to add 4x squared plus 7, take the derivative of that. This is just 3, right? X turned into 1, and then the number turned into 0. So this means we have 3x minus 2 times an 8x plus 4x squared plus 7 times a 3, right? So if you get to this part, I'm pretty happy. It means you know how to apply the product rule. But you can go a little bit further. For simplifying, that would give us 24x squared minus 16x plus, when you distribute, right? This times this, this times this, this times this, this times this. So that would be 12x squared plus a 21. Any like terms? We look like this is like term here. 24 plus 12 is 36x squared minus a 16x plus 21. So that would be our final answer. All right. And then number 12, we are going to have f of x equal to 8x to the 5th power and then 3x plus 5 to the 3rd power. So that look like a product and the chain rule together. So we're going to have applying of x. Product rule first. So first term, take the derivative of the second part. And then adding the second part, take the derivative of the first. Okay. 8x to the 5th power, this is a chain rule, so we're going to need to do outside and inside, right? So the outside we put down the 3x plus 5 go down 1 degree is 2, and then we also need to take the derivative of the inside part, 3x plus 5 prime, right? So this is the outside and inside for the chain. And then on the second part, we're going to have plus 3x plus 5 to the 3rd power. Take the derivative of 8x to the 5th. It's going to be 8 times 5, x to the 4, right? Okay. Now, 8x to the 5th power, here we have 3 times 3x plus 5 squared. Take the derivative of this part is just 3, right? Plus a 0. Okay, and then adding my 3x plus 5 to the 3rd power. This together would be 40x to the 4. So clean that up slightly. 8x to the 5th need to multiply 3 times 3x plus 5 squared times a 3. Alright, it looks like we have this term can multiply all this number together. 8 times 9 basically is 72x to the 5th. This is 3x plus 5 squared plus a 3x plus 5 cubed, and then 40x to the 4. So I didn't multiply them together because I see like they are the same. So if you get to this point, I'm pretty happy with you because it shows that you know how to take the derivative. Your book may ask you to go a little bit further by factoring. We can see both of these have number, right? And both of these two numbers can be divided by 8, and they have x to the 4 in common. So I can pull a GCF of 8x to the 4, and both of them have 3x plus 5, right? And 3x plus 5, they have up to 2 in common. So after we pull that out as GCF, 72 divided by 8 is 9. I pull out 4 out of 5, so I have one more. I pull out the whole thing here, so that's it. Adding, this guy is going to have a 3x plus 5, one of them, and 40 divided by 8 is going to be 5. I pull out all the x here. So I'm going to combine this in here. This would be 8x to the 4, 3x plus 5 squared. Inside here we have 9x plus, multiply here, we get 15x plus 25. So the x part can be combined, I guess. So this would be 8x to the 4, 3x plus 5 squared, and then inside we are going to have 15 plus 9 is 24x plus a 25. So that would be final answer. But if you can get to this part, it's not bad. You can get most of the credits. Alright, so that's number 12. Let's move on to 13. Number 13, we have a function. Oh, I'm sorry, this is supposed to be f of x. It's going to be 3x squared minus 5x plus 4. Slope of the tangent line. So slope of tangent line means f' of x at this point. So I need slope of tangent line first. Slope of tangent line means I need to find f' of x. So if f of x is 3x squared minus 4x plus 4, taking the derivative of that is going to be 3 times 2x, right? Minus a 5. This x is going to turn into 1, right? And then the number is going to turn into 0. So f' of x is going to be 6x minus 5. Are we okay? The slope of tangent line, but they want it at 2, negative 4, meaning x equal to 2, right? So I need to plug it in here. F' of 2 is going to equal to 6 times of 2 minus a 5. That would be 12 minus 5, and I get a 7. So the slope of tangent line is 7. Slope of tangent line at 2, negative 4 equal to 7. And then the second part, the A is slope of tangent line at any point. So this is slope of tangent line at any point. This is slope of tangent line at this particular point. So this should be B part. And the C part, I'm going to correct this before I give it to you, okay? The C part is by an equation of tangent line at that point. So when you do equations, because we just have random point, we're going to use point slope y minus y1 equal to m times x minus x1, right? So this is the point slope formula. We're going to need to plug in one point, which we have a point here already. The point is 2, negative 4. And then we also have my slope equal to 7, right? So whenever you just found the f' of x, that represents the slope of tangent line at any point. And then if you wanted the slope of tangent line at a particular point, you plug in that x value for f' of x. And now we need the equation of line, so we use a point and the slope to plug in, right? Y minus something, slope x minus something. So the point x and y, x is 2, y is negative 4, and my slope we found out earlier was 7, right? Y plus 4 equal to 7x minus 14. Move the 4 to the other side. Y will equal to 7x minus 18. That would be the equation of the tangent line. at the point 2 comma negative 4. Okay, 2 more questions. Okay, number 14 next. A number of viewers of a television series introduced several years ago is approximated by the function. So they have a function that is n of t equal to 8 plus 5t raised to 1/2 power. This is between 1 and 52. So n of t is measured in millions, so keep that in mind when you do your answer. This is in million. It's representing the number of weekly viewers of the series in the t week. So between week 1 to week 52, right? How many viewers were there in week 25? Found the rate of increasing of the weekly audience at the end of week 25. This one we need to find the, for A, they just want to know how many viewers, right? That's not a rate of change. So I just need to plug in t equal to 25 from the original function, right? So I can find out what is the viewer number in week 25. N of 25. And we're pretty sure no 1/2 power is square root, right? Equal to square root of 8 plus 5 times 25. So 5 times 25 is 125. It's 8 plus 125. That would be 133. That's not a nice number, so we're going to need the calculator. If we plug in square root, which is second here, on top of x squared, 133, we got a decimal number, right? So I'm going to write down 2 decimal places, 11.53, but don't forget this is in millions viewer. This is how many viewers we estimate to have in week 25. So in week 25, we have about 11.53 million viewers. So for the B part, need to find the rate of increase. So this is rate of change, right? So rate of change at the end of week 25. So the t equal to 25 again, but this time it's rate of change. So I'm going to need to find n prime of t, right? So when we found n prime of t, we just take the derivative of that. Let's see, we will pull down the 1/2. This is like a chain rule, and write down 8 plus 5t. This is to go down 1 degree, right? Minus 2 over 2, and then need to take the derivative of the inside part, 8 plus 5t prime, right? So now we have 1/2, 8 plus 5t. This is negative 1/2. Take the derivative of this would be 0 plus 5, right? Constant becomes 0, t is 1, so just 5 here. Let's clean that up. That would be 1/2, again, 8 plus 5t raised to negative 1/2 power. And I know we cannot keep negative exponents, right? But this is multiplied to a 5. So let's write that as a fraction. This will give me at the bottom, I have denominator 2, I have this is negative power, so go down. Become positive exponents, but the 5 will go to the top. That would be my n prime of t, right? So that's the rate of change functions, but they want it to be at week 25. So I'm going to need to plug in n prime of 25 in here. I'm going to have 5, 2 times 8 plus 5 times 25. Need to raise to 1/2 power, or you can take square root of it. Either way. This is 5. We have a 2 square root of 8 plus 125, right? So that would be 5, 2 square root of 133 again, right? So put it in the calculator. I don't think I can do it by hand. 5 divided by parenthesis 2 square root of 133, close it. Okay, So you have to be very careful when you do this, okay? Because if you do 5 divided by 2, that would be like a fraction. If you don't put the bottom part in the parenthesis, your answer is going to be wrong, okay? The answer should be about 0.22 if we round it to 2 decimal places. But don't forget this is in millions, right? So it's 0.22 millions of viewers increase per week. So this is the rate of increasing at 0.22 million viewers per week at the end of week 25. So if you need to write an answer statement, that would be like that. So the rate of increase is 0.22 million viewers per week at the end of week 25. Okay, because when you take the derivative, it represents the rate of change. All right, so that's number 14. Last one is number 15. So number 15, we have an annual sales in millions of dollars again. So I know DVD recording is not as popular nowadays. We're streaming now. Of a DVD recording of a hit movie in years from the date of its release is given by S of t. So we have this rational functions. Find the rate at which the cells are changing at time t. So rate of change. And then the second part would be the cells in year 1, and then the cells in 2 years. And then, so those are just like regular cells. We can plug it into the original functions. But when they say how fast is it changing, that would be rate of change, right? How fast is it changing in year 1 and 2? Those would be S prime of t. So let's start with A. A is the rate of change. So we need to find S prime of t. So number 15, we have the S functions. S of t equal to 5t, t squared plus 1, and we do S prime of t. This is the quotient rule, right? So the bottom part need to do what? Square. Start with which part? The bottom part. And take the derivative of the top. Add or subtract. Subtract, and then you use the top part first, and take the derivative of the bottom part. Okay? Clean that up a little bit. T squared plus 1 perfect square on the bottom, and then we have t squared plus 1. Take the derivative of that, it's just 5. The t become 1, right? 5 times 1 minus, we have 5t. Taking the derivative of that would be just 2t, right? And the number turned into 0. Hopefully by now you are getting better at this. And we will clean that up further. So this would be 5t squared plus 5 minus the 10t, because this is distributed like that, and this multiply together. And at the bottom we have t squared plus 1 squared. I'm sorry. So when you distribute, this is 5t squared plus 5. And then minus 5 times 2 is 10, and t times 2 would be t squared. Okay, so we can combine some terms. We have 5t squared minus t squared would be a negative 5t squared. So the cell seems to be decreasing over time. T squared plus 1 perfect square. That would be S prime of t. So this will represent the rate of change at any time. Rate of change for cells at any time t. So you can plug in the t to find out, right? Just be very careful for the B and C part. They just want the cells in year 1 and 2, right? So we can use the original cells functions. So for the B part, cells year 1. So it's going to be S plug in 1. You have 5 times 1, 1 squared plus 1, right? 5 times 1 here, 1 squared plus 1. So year 1, we're going to have 5 over 1 plus 1, so 5 divided by 2 is 2.5. This is 2.5, but it's in millions of dollars, so it's going to be 2.5 millions of dollars for sales. That's for year 1 sale. And then C want to know the year 2. C is sales in year 2. S of 2, 5 times 2, 2 squared plus 1. 5 times 2 is 10. This is 4 plus 1. So 10 divided by 5 is going to be $2 million of sales in year 2. Which makes sense because once it's released, people are not as excited after a year. D, say they want to know how fast is the sale changing of DVD 1 year after it's released. So we need the rate of change, right? So rate of change in year 1. So it's going to be S-prime of 1, right? Because it's rate of change. So I need to find my S-prime functions, plug in 1, right? So negative 5, plug in 1 square, plus the 5. This is 1 square plus 1 in the bottom, perfect square. That would be negative 5 plus 5 on top. This would be 2 square. So anyhow, it's going to be 0 over 4. That means 0, right? This means it didn't change in year 1, the rate of change. So it's no change in year 1. No change of sales in 1 year after its release. The last part is E. For E, they want to know how fast is it changing for the sales in the 2 years after it released. So again, it's rate of change. And 2 years, so we need to use the S-prime formula, plug in 2. We got negative 5, plug in 2 square, plus the 5, 2 square, plus the 1 square. So plug in 2 there. That is going to give me a negative 5 times a 4 plus the 5. At the bottom we have 4 plus 1 perfect square. So that would be negative 20 plus 5. This is 5 square. And that would give me a negative 15 over 25. If you use your calculator, negative 15 divided by 25 is going to be a negative 0.6. This is millions of dollars for the sales, right? 2 years after its release. So it's not as popular and fresh anymore. At the end of the 2 year after it released, the rate of change is decreasing 0.6 millions of dollar per year at the end of the year 2. So some of these questions will ask you to write answer statement, so you will need to explain what those numbers be. So the last one, just be careful when you just need the sales, you just plug in the original function. But if you're looking for rate of change, then you use the derivative as prime of t to plug in those numbers, okay?